Okay, let's talk really about two things, but it's going to be kind of the same discussion. The first one is the average value function, and that's sort of a precursor to the mean value theorem. For integrals. And remember, we have one for derivatives also for the mean value theorem. So this one specifically with integrals. And this one is neat, kind of as this name would imply, and also mean value theorem. What we're going to use in this is we're going to use integrals to figure out the average value of a function over a given interval. So maybe that's, think of the question that this answers would be just that. What the average value of a function over a given interval. And so you can see there's a lot of applications for this, like, if you think of, if you're trying to find, like volumes or center of mass or things like that, this can be a really, really useful theorem. So if you want to think about it in terms of, I guess more geometrically, what we're doing is you can always find a constant function that will form a rectangle that will be drawn by the same width as the area of the function. So that's a little bit more complicated. So let's kind of break down what that means. So first off, I'm going to give us, here we go. So we have some constant, right? So it's going to be just a straight line on a graph, and that is 1 over b minus a with the integral from a to b of your function f of t dt. So let's take a look at this in action. Let's use a fairly easy equation. Let's say f of x equals x squared. And we'll go just, let's do from 0 to 2. Okay, so here's the graph of our function. So we'll put just a few lines there, and then 1 and 2. All right, so let's sketch this out. Here's 1, and here's 2, and then 1, 2, 3, and 4. Okay, so we start at 0, 0, then we go to 1, 1, because 1 squared is 1, and then 2 squared is 4, so there's, might as well label those out. Okay, so let's draw this. So here's what this is saying from the mean value theorem, is this area underneath this curve can be represented with an equivalent area of a rectangle. So wherever this f of c is, you can just draw a straight line across, and then the area of this shaded line that I'm shading right now would be the same as that shaded line. So you find this average value of this function, and then those two areas would be the same. Okay, so let's do that. Let's use this equation. So I know that this f of c, so we're going from 0 to 2, so that is going to equal 1 over 2 minus 0, integral from 0 to 2 of x squared dx. All right, so let's see. Let's keep going. 1 over 2 minus 0, that's just 1/2 times. Now we got to figure out what this is. Well, remember, we just take this number and add 1 and then divide it by that number. So this is going to be x cubed over 3. And then this one is going to be from 0 to 2. All right, well, one more step. 0 is just going to be 0, right? 0 times 0 is just 0. So let's figure out what it is at 2. Well, 2 cubed, 2 times 2 is 4, times 2 is 8. That's 8 over 3. So I know that 1 times 8 is 8, and 2 times 3 is 6. So this constant function, this value is going to be at 4/3 or 1 1/3. So, hey, what do you know? We were pretty close. So if I took a line right here, so this line 4/3 represents the average value of all these from here to there. And consequently, the area of this shaded region is going to equal the exact same area of this shaded region if we shaded this rectangle in. So that's what it means when you have a rectangle drawn with the same width, the width is the same, that will have the same area as this area under the function. All right, and now we can double check ourselves if we want, just for fun. So let's see, we'll just say double check. All right, so we're going to take the integral. Can you all see that? Yeah, let's focus that a little bit. Okay, so we can take the integral from 0 to 2 of x squared dx. Well, that just equals x cubed over 3 from 0 to 2. So let's see, this 2 cubed is 8, so that's 8/3. Now you might say, okay, well wait a second, why is this 4/3 if we're double checking ourselves and this 8/3? Well, one thing that you have to remember is we're finding this area, right? This is the area under the curve. So this we have to multiply by 2, right? Because this is, here is 4/3, right? So if we want to find the area is going to be 4/3 times 2. So you can see, there we go, that we know that this area is going to be, the area of this rectangle is 8/3. And we know that the area total underneath this curve is 8/3. So this, not to be confused, this is sort of separate, I guess you could say. The don't get confused when you're looking at your notes. F of c, when you find f of c, that's just this constant function. It's going to give us the average of, if you averaged up every single value, every single number in this function on the y-axis, this is what average value you would get. But then also, if you want to find the area of that rectangle, then you can multiply it by that too. So just don't get confused there. And then we see that with our double checking that it works. So we can be fairly confident that we have figured out the correct constant function. Okay, I hope that helps. Let's just kind of go from there, and that should give you a good jump on the mean value theorem.